We're solving problem 25 from the 2019 AMC12A. This is solution number 1. Let triangle A0, B0, C0 be a triangle whose angle measures are exactly 59.999 degrees, 60 degrees, and 60.001 degrees. For each positive integer n, define a sub n to be the foot of the altitude from a sub n minus 1 to line b sub n minus 1 c sub n minus 1. Likewise, define b sub n to be the foot of the altitude from b sub n minus 1 to line a sub n minus 1 c sub n minus 1, and c sub n is to be the foot of the altitude from c sub n minus 1 to line a sub n minus 1, b sub n minus 1. What is the least positive integer n for which triangle a sub n, b sub n, c sub n is obtuse? So we have this triangle ABC, and it's almost equilateral. And in case if you can't really see what's going on, you have this triangle, A, B, and C. You drop an altitude from A, you drop an altitude from C, drop an altitude from B, and you have A1, B1, and C1. Now the angle measures slightly shift in this, but this is very rough, as you can see, because C is offset by a lot. But basically, they form a new triangle like this. And then this is the first triangle formed, and then you would do another triangle with these 3 points. That would be sub 2, A sub 2, B sub 2, C sub 2, and so on. So what we want to do is we want to draw these lines, and what we really see is that we have things that stand we have some things that stand out. So if you have we see that, although it might be hard to see, there's a center point here. There's a point here. That's A sub 1, C sub 1, and B sub 1. We see that there's a quadrilateral A sub 1, the middle point, C sub 1, and B naught. Same on the other side, and we see that these are can be inscribed in a circle. So therefore, we can say that the angle measure of A sub 1 is 180 degrees minus 2 times the length of angle measure A0, which we can just assign angle measures to A1, to A, B, and C. So let A0 be the 59.999. So this is 60.002. So then we set B1 is 180 minus 2 B0. Let's just assume this one was the 61. B0 was 60, so B sub 1 is 60. And then C sub 1, C gets whatever's left. So C naught is 60.001 degrees. So this would be 59.998 degrees. So here we have our degree measures. What we see in general is that A sub n is equal to 60 plus 0.001 times 2 to the power of n. B of n sub n is 60, and C sub n is equal to 60 minus 0.001 times 2 to the power of n. We want it to be an obtuse triangle. So for our answer of this problem, we know that A sub n, or 60 plus 0.001 to the power of 2, times 2 to the power of n, has to be greater than 90 degrees. Subtract 60 from both sides, 0.001 times 2 to the power of n has to be greater than 30. 2 to the power of n has to be greater than 30,000 when you multiply both sides by 1,000. And now you can use rough values. We know that 2 to the power of 10 is 1,000 about. 2 to the power of 11 is 2,000. 2 to the power of 12 is 4,000. And right now you should probably be getting around close there. But we see that when n is 15, that's the first number of times you have to repeat this triangle process for the triangle to be an obtuse triangle. So this is going to be your answer and how we solve it for solution 1.